Hello guys, welcome again to today's lesson where we'll be doing the similarity. We are still doing the grade 12 Euclidean geometry. We just now moved to the next part. We are done with proportionality theorem, ratios on the same line, multiple ratios on the same line, ratio of areas or area ratios, right? Okay, now we move to the next part, which is similarities. So, what do you guys know about the similarity? I assume you guys learned about similarity somewhere in grade 8 and grade 9, right? So, similarity are polygons that are said to be similar if they have the same shape, but not necessarily the same size. So, as long as those shapes are the same in the size, and then some sides are proportionally, then those shapes are similar. So one shape can be 2 times the other, or one shape can be half times the other. You guys get that? Okay. So now there is a difference between a congruency and similarity, because congruency, they have to be exactly the same. Then if we are talking about two polygons or two shapes, they exactly have to be the same with angles, with the sides, with the shape. That is congruency. Now we are talking about similarity. They are not necessarily the same, but they are similar. Okay, if two polygons are similar, the one is an enlargement of the other. Like I said, the other one can be 2 times the other one, or the other one can be 3 times the other one, or the other one can be half times the other one. Right. Now, formally, we say that two polygons are similar if and only if all pairs of corresponding angles are equal. Okay, can you hear that? This bullet is only talking about the corresponding angles only. Now, when we look at these polygons here, this angle is equal to that angle, this one is equal to this is equal to this is equal to this is equal to this. Okay, let's go to the next bullet. And all pairs of corresponding sides are in the same proportions. So note that the pairs of corresponding sides are not equal, but they are in the same proportion, right? So note that the only thing that is equal here in this shape is the corresponding angles, but the corresponding sides are in the same proportions. Okay, let's go. Both of these conditions have to be met in order for you to prove that two polygons or two shapes are similar. These two conditions have to be met. But in order for you to disprove that or to go against that, as long as one of these conditions is not satisfied, then you disproved that certain polygons or certain shapes are not similar. Okay, let's go to the next part. Triangles. For triangles, any one of two conditions, equal angles or proportional sides, is sufficient. Okay, to guarantee the similarity. There are theorems which states that if any one of the conditions applies, then the other condition will automatically apply as well. This only applies for triangles. This is only true for triangles, right? So as long as one of these is true, then automatically the other one will be true. If you show that, let's say this is my triangle 1, and you shown that this is triangle 2, that this angle is equal to this angle is equal to this angle is equal to the angle, automatically this will hold automatically. Then we have proven that these triangles are similar. Or if maybe you have shown that now, okay, this is triangle 1, this is triangle 2, you've shown that this is the corresponding side to this one. Those sides are in the same proportion. These and these are in the corresponding sides. They are in the same proportion, this and this. the same proportion. Again, if you show that, this will automatically hold. Only if we are talking about triangles. You have to note that. Okay, now thank you. Let's move with this one. For all other polygons, the two conditions for similarity have to be established separately. If you are talking about the square, rectangle, any other polygon, you have to show these two conditions. Note that it's only for triangles where you only have to show one. If one is holding, then the other one will hold, definitely, automatically. Now, the notation for this thing is that, okay, they made an example with the triangles here for some example. With triangle CAT, which is this one here, and the triangle DOG, this side. Means triangle CAT is similar to triangle DOG. So note that this sign that has got some vertical three lines is for similarity, and the ones with three horizontal lines is for congruency. Yes. So the one with horizontal three lines is for congruency. The one with three vertical lines is for similarity. Fine. Now, in this notation, in the order in which letters are written is very, very important, as it indicates which angle are equal. Okay, fine. Let's have a look here. They say triangle CAT or triangle cat is similar to triangle duck. Oh, wow, cat and duck. CAT is similar to triangle DOG. Fine. Now we will go to the angle C, which is the first angle on the cat, will be similar to angle GD, which is the first angle on the triangle TOG. Fine. We go to the next one, which is A. We can see that A is equal to the other one O there, the second one on the DOG. Okay, then the third one is T. There we can see T is equal to the third triangle on that dog triangle, which is G. And remember, in Euclidean geometry, let's say you are given some certain triangles there somewhere, and then you have to prove some similarity. I told you guys earlier on that you have to play around your reasonings. You provide a statement that C is equal to D. You give it a reason behind that statement. You give a reason, you give a reason. So, in order for you to get full marks, this is Euclidean geometry, guys. You can't just get full marks if you only provide the statement. You have to accompany that statement by some valid mathematical Euclidean geometry reasoning. Yes. So now you will, whether you are given that this is equal to that, then you will write that is given. Or maybe this is equal to that. Why? Because this and this are parallel. This and this are parallel. But you have to provide some reason. Okay, fine. I hope that makes sense to you guys. Let's move to the next part. Yeah, so the order also indicates which ratios of the side are equal. If you take the first two letters in this triangle, you will also have to take the first two letters on this triangle. So the ratio of this side CA will be proportional to the ratio DO. Same applies AT, OG, and maybe C and T, DG, CT, DG. Just like that. Okay, let's move. Now here, okay, they took C and A, the first two letters, all over the O. That will be equal to AT all over, you go ATOG. That will be equal to CT and over the G, just like that. I hope this makes sense to you guys. Okay, this is what I just talked about. Okay, and now here you can just take only two. You take this, you put, or you take this, you put, or you take this and this, you put them. But now, when you put your reasoning on this, your reasoning will be from similar triangles. Okay, fine. You guys will see that as we proceed to the next example. Now let's move to the next part. They are saying here the triangle similarity theorem. In grade 12, guys, if I'm not mistaken, but I will confirm that, I think we have three theorems, which is proportionality theorem, similarity theorem, and Pythagoras theorem. Then, on top of these three, you will also be required to know the theorems from grade 11. So you guys shouldn't forget those many theorems from grade 11 in circle, Euclidean geometry, tan chord theorem, angle at the center 2 times angle at the circumference, line thrown from the center bisects the chord, which one else? Angle outside the cyclic quadrilateral is equal to the interior opposite angle of the cyclic quad, and then we have got opposite angles of a cyclic quad are supplementary. What do we mean by supplementary? They add up to 180 degrees. What else do we have there? We have equal chords subtend equal angles and the angles in the same segment. And okay, if it happens that I forgot some, then you guys can go to your textbook and refer. But you guys should know those theorems. Even though in grade 12, you only learn three theorems: proportionality theorem, similarity theorem, and Pythagoras theorem. You also have to know those grade 11 theorems. You will be examined on those theorems, guys. It is wise for you guys to know those theorems because I think Euclidean geometry on your final paper and trial paper, it weighs 40 to 50 marks. So that is a lot, guys. You guys have to know that. So, okay, let's go back to theorem 2, the triangle similarity theorem. They say, if two triangles are equiangular, oh, I hope that already says something to you. Equiangular, equality of some angle. Angular talks about angle. Equi talks about something that is equal. Okay, then their corresponding sides are in the same proportions, and hence the triangles are similar. Okay, what do we mean if triangles are equiangular? These triangles have got corresponding equal angles. This angle corresponds with that angle. Therefore, this angle is equal to that angle. This angle corresponds to that angle. Therefore, this angle is equal to that angle. This angle corresponds to that angle. Therefore, this angle is equal to that angle. What does that imply? That implies that the sides that correspond in these triangles are in the same proportions. Therefore, triangle 1 and triangle 2 are similar. Okay, now what can you do if you are given that triangle ABC, which is this one, and triangle DEF, with something that we are given here, that A is equal to D, B is equal to E, C is equal to F. Fine. Now we can just come to their corresponding sides. We make some ratios. This, which is AB over DE, that will be equal to AC over AF. Okay, BC over EF will be equal to those equalities. Why do we say that? Oh, we are talking about a similarity. What is the reason? Why did we say that? It's because we are given the triangles that are equiangular. This angle is equal to that angle, 1. This angle is equal to this angle, 2. This angle is equal to this angle, 3. Therefore, we talked about three angles: angle, angle, angle. Or you can write it like this: angle, angle, angle. Yeah, A, or these the sides: angle, angle, angle. Fine. Now, let's move to the next part. Using angles to prove that triangles are similar. We can prove that two triangles are similar by showing that all pairs of corresponding angles are equal on the triangles. If we can show that any two pairs of corresponding angles are equal, then automatically the third pair of triangle of those triangles will be equal, since the three angles of both triangles must add up to 180 degrees. Fine. Now let's just have a look on this example 14 here. I will just explain the solutions, because what I can write here is exactly what is written already here. Now, guys, please don't forget to just fully read and understand the statement, just to ensure, or just to be sure of what you are given. You will use what you are given to get what you are required to find. So they are saying to us, in the sketch alongside, we are given that AB is parallel to DE. AB is parallel to DE, and AC is parallel to FE. We see that. Now, we are required to prove that BCA is similar to triangle DFE. DFE here. Fine. Now, how can we do that? You can simply write your triangle BCA here. You take the first letter, you write it as the angle, because yes, the first letter in your triangle there, it appears as the angle B, then it is B. Yes. You come to see on BCA, C there, it exists as C1, which is the angle in the triangle BCA. Then you write your C1. You come to A, there is A, you write it there accordingly. Now, you come to this other triangle. Now, you will see which angles in this triangle that are equal to these angles. Angle B, this is B. On this triangle, B will automatically be equal to D because of this Z here. So what is the reason behind that? It is alternate angles. Then you state your parabola, right? So I always say this to the students that I'm teaching, guys. I always say math is fun, right? Oh, yes, math is fun to everyone. Now, wherever you see some lines that are this, and then you can just extract some lines that forms an F with angles like this, then this one will be for corresponding angles. Then those lines will be equal to each other. Then for some angles that can form something like these angles are inside these lines. These ones form co-interior angles. But with this one, note that these angles are not equal, but these angles are supplementary. Remember, we said supplementary. Those angles add up to 180 degrees, or those angles sum up to 180 degrees. Those angles are supplementary. Now, this angle plus this angle is equal to 180 degrees. That is called interior angle. But now, if your angles form something like that or N, now that is alternate angles. Alternate angles. But with these things, as long as you use something like math is fun, corresponding angles, co-interior angles, alternate angles. Please, guys, don't forget. You also have to specify or note or state those parallel lines that you used there. Just like here, they said B is equal to D. Why? Because those are the alternate angles. Why do we say those are the alternate angles? Because AB is parallel to DE. Yes, just like that. Now you come to C1. C1. Which angle is equal to that? C1. Oh, I have this part here. C1 is equal to F1 right there. Okay, they forward something like 1 there is equal to F1. Why? They form something like that. From my math is fun technique, there at N or Z. What is the reason on that part there? It is alternate angles. Why alternate angles? Because AC, which is this one, is parallel to FE, right? I hope that makes sense. Then now the third one, oh, automatically that will be equal to this one. This angle will be equal to the other angle that we haven't mentioned in this triangle. What is the reason? Is the third angle of the triangle. So guys, if you have mentioned that the first two corresponding angles are equal to each other, automatically the third corresponding angles will definitely be equal to each other. Therefore, now the triangle BCA is similar to triangle TFE. Why? We use the three angles, therefore the reasoning will be angle, 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 right? Right. We are done with the solution for A. Now let me go explain the solution for B. B, they say prove that AB times EF is equal to AC times ED. Right? Oh, this is interesting. You might be scared. Oh, this is not scary at all. Okay, they have something here, but I'm not sure if this thing that I'm going to talk about here is going to make sense. You have this thing here, you have this thing. You just take this one to be the denominator of that side, and you take this one to be the denominator of this side. Therefore, you will have AB over AC is equal to ED over EF, right? You have something like this. So AB over AC, that is equal to ED over EF. I'm sorry, is supposed to be EF. Why this? Why this ratio is equal to this ratio? Because that is similarity. That is from similarity triangles. Of course, this is that AB and AC here. ED, there is ED here, and then there is EF. Of course, on the previous question, we have proved that these triangles are similar. Therefore, this ratio is coming from the similar triangle, right? Yes, you can do this, or you still can go to what we have learned from this part for corresponding sides. This and this, this and this and this. You equate to come up with this one to prove that similarity thing. Now, if you are having this thing now, you will just have to prove that now. I'm sorry for this sound that is coming up on my background, guys. It's just someone who's calling. Now, in this thing here, you will have to form some triangles on this side and on this side to prove a similarity here, and then afterwards you can come up to your conclusion. You take the triangle ABC. Here is ABC. Where is it? ABC. Then ABC. Then you prove the similarity and EDF. 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 So now you see that if you were not given or you were not asked this question, you are just asked this one. You can just use this information like this and to form these triangles and prove the similarity here. Then now, from this triangle, you take this over this, okay, which is AB over ED is equal to this over this. BC over DE. DE is equal to, you take this, AC over what is this? My bad, my handwriting is bad. This was EDF here, then F here. And then now you can go for the ratio that will give you this part. AB times EF, AC, and ED. You definitely will go for this ratio and that ratio. AB over ED will be equal to AC over EF. Then now you cross multiply. Okay, why do we say these ratios are equal? Because it comes from those similar triangles. Okay, I just went for this method in case if you were not asked to prove the similarity. You are just given this And then you can just use this information to construct your triangles and prove the similarity, and then just use the corresponding letters to form your ratios, and then at the end you will come up with this thing. But otherwise, if you were asked or required in the previous question to prove that similarity, you can just use BC over DF. BC over DF is equal to CA over FE. CA over FE is equal to BA all over DE, just like we have now. Then now, you can just look for the letters that you are having here so that when you cross multiply something here, you will end up having something there. And then here, your reasoning behind this statement will definitely be similarity triangles. I hope this makes sense to you guys. Therefore, now we can just, guys, end here for this lesson. Then I will now see you guys again in the lesson. Thank you, guys.